In this video, we're going to take a look at solving systems of equations by graphing. In particular, we're going to be looking at linear equations, and we're going to look for them in the form of y equals mx plus b. This will make them easy to graph. Just identify the y-intercept and the slope. And the different outcomes you're going to have is you'll either get one solution when the two lines intersect from different slopes, or you'll have no solutions if they're parallel lines with the same slope but different y-intercept. And there'll be a third case where you have infinite solutions if they're the same line. So let's go ahead and take a look at 4 different examples. This first example is one of the easier ones. What we like about it, it's already written in the form y equals mx plus b, also known as slope-intercept. So if we identify the y-intercept first, that is the single number on its own, plus 9 in this case, we can just go to the y-axis and put the point 9. So there we are on the y-axis. And then the number multiplying the x in this form is the slope. So in this case, the slope is -3. And we like to look at slope as a fraction. So we'll look at this as -3 over 1. Now, the fact that it's -3 tells me I'm going to be going down. You may be familiar with looking at slope as rise over run. Well, if we have a negative number, instead of rise, let's think of this as a fall. And instead of run, we're always going to think about going right so we don't get confused. So in this case, we're going to fall 3, 1, 2, 3, and we're going to run 1, right 1. So down 3, right 1, down 3, right 1, and we just continue on down like this, and we can put another point down here. And then we're just going to connect those points as best we can for our line. So we have a constant slope of -3. So if you have just a number by itself for slope, realize you're going to go right 1 for the denominator. Now our second equation is 1/2 x minus 5. So in this case, -5 is our y-intercept. So let's go over to the graph, take a look at -5 and put our point on the y-axis. Now our slope, or our multiplier of x, is 1/2. So in this case, that means we're going to rise 1, or go up 1, and we're going to go right 2. Now, we can also think of this as 1/2 over 1, so we can go up a half and over 1, but that could be a little tricky on graphs. But let's take a look. So here we are at -5. We're going to go up 1 over 2. Up 1 over 2, and there's our intersection point, but let's continue up 1 over 2. Now, if I go back to the y-intercept and I go up a half over 1, notice it's still going to follow the same pattern. But again, it's easier to use the 1 and the 2 for counting purposes. Now we still have to identify our solution, and our solution is where the two lines intersect. And we're just going to follow this up to see what the x value is. So in this case, x equals 4. We can go back to the y-axis to see what the y value is. So it's y equals -3. So our solution to this problem can be written as a coordinate point 4, -3. Our second example, you see that it's not written in the form we want, at least our first equation. So we're going to look to rewrite this equation in slope-intercept form, mx plus b. So let's rewrite that down here, 2x plus 3y equals 12. So the first thing we'll do, we'll always get rid of the x term when it's written in this form. So we're going to get rid of this 2x by subtracting it from each side. And when we do that, we're left with 3y on the left-hand side. And we could write 12 minus 2x, but usually we'll put our x term first. So we're just going to keep it as minus 2x or -2x. And then we have a 12. So we're just going to add that on, plus 12. Still need to get y by itself. So we're going to get rid of multiply by 3 by dividing both sides by 3. And when you divide both sides by 3, make sure you distribute the 3 to each piece. So now we have y equals, and here we'll have -2 over 3x, so there's our slope, plus 12 over 3 is also 4. So our y-intercept is a positive 4. Go ahead and put that point. And our slope, let's write that here, is -2 over 3. So this means we're going to go down 2, right 3. So down 2, right 3, 1, 2, 3. Down 2, right 3, 1, 2, 3. And we'll follow that pattern. And we can also go backwards from the y-intercept. Instead of going down 2, right 3, we can go up 2, left 3, and put a point. And we'll connect those points to make our line. Now, our second line is a little bit different. We have x equals 3. So notice it's x equals a single number. And when you have that, you're going to have a vertical line. So you're going to go over to x, and we're going to mark that off. X equals 3. So x is always 3, and that's why it's a vertical line. Some people get confused with the x value, but notice we're always 3 away wherever we are on this line. If we had y equals a number, we'd have a horizontal line. So let's go ahead and look at the solution. This is where our points intersect. So notice it's already marked here for us that x has to equal 3, which makes a lot of sense. And if we look at what our y value is, y equals 2. So our solution here is the point 3, 2. In example 3, we'll notice one equation is already in the proper form, so a lot of times it's a good idea just to go ahead and take care of that. So let's go ahead and take a look. We have a y-intercept of -5, so we'll go to our graph and put that point on -5 for the y-axis. Now we see our slope is 1/2, and we've seen this before. So we're going to have a rise of 1 and a run of 2, or go right 2. So let's go up 1 over 2, up 1 over 2, up 1 over 2, and so on. And we can go ahead and draw our line. Now our second equation, we need to do a little bit of work. So let's rewrite that. -4y plus 2x equals 2. As we said before, we're going to move that x term first. So if we have plus 2x, we're going to write minus 2x on each side. So that term is gone. That leaves us with -4y equals, again, we'll put our x term first, -2x, and that's going to be a plus 2. Now, we'll get rid of multiplying by -4 because that's the action being done to the y. So we're going to divide each piece by -4. And in doing that, we are left with y equals -2 over 4. Two negatives make a positive, and 2/4 simplify to 1/2 x. And then 2 over 4 is 1/2 and different signs, so it's going to be minus 1/2. So something I really want to point out to you here is the fact that we have the same slope but a different y-intercept. Let's see what that means. So our y-intercept is -1/2, so that's a point right there. Now, this is where we said we can use that strategy from earlier. If you have 1/2, you can think of it as going up 1/2 over 1. Now we have a nicer point to work with. Now we're going to use that rise of 1 and the run of 2. Now that we have a nice point, and we can go back here. So you'll notice when we graph this, when they have the same slope and a different y-intercept, they're parallel lines. So when we have parallel lines, we're going to have no solution. So let's write that down. And you can either write the phrase no solution, or you can use this symbol, which means the null set, which basically means no solution. And our final example. So first, let's take a look at, let's go with our second equation here. This one looks easier. So in this case, we just need to isolate the y. So we're going to get rid of multiply by 2. We'll divide both sides by 2. That leaves us with y equals, and now we have 2x minus 1. Okay, so let's go ahead and graph that. So here we have -1. And now, just to make sure we're good, when we have m equals 2, we rewrite it as 2 over 1. So make sure we go up 2 and over only 1. Up 2 over 1, up 2 over 1, and so on. And we can go down 2, back 1. So with that is our slope of +2. And you can always compare it to the idea of a slope of 1, and it's steeper. Now let's take a look at our other equation. So in this case, we're going to have to get rid of this plus 2x. Let's go ahead and write it here. -y plus 2x equals 1. So we're going to subtract 2x from each side. And in doing that, we have -y equals, those are gone, and we have -2x plus 1. We have to take care of this negative sign. So what we can do is we could divide both sides by -1. And again, we distribute. So we are left with y equals, we'll have 2x and then -1. So there it is. Notice we have the exact same equation. So if we were to go ahead and graph it, notice all our points intersect. It's the same line. So in this case, you are going to have infinite solutions. So you can write that down, and sometimes you can identify this is what's called a dependent system because there's more than one answer. The answer to y depends on which x we choose. So there are 4 examples. I hope that helps.